Okay, guys, so we are starting a brand new unit, weathering and erosion. Please follow along with your notes. I would suggest handwriting. If you can't, use DocHub. You can use regular Google Docs. Either one. Make sure you're doing your notes along with this. Okay, so the first thing we have is the hydrological cycle. You have a picture very, very similar to this. I think it's the exact same one. Although I did add right here, which you could do, and right here, which you should also do. So what we're going to start out with is the water cycle. It's also called the hydrological cycle. And we're going to start over here. I like to start at the left-hand side. I don't know why, I do. So after you have these clouds, you have precipitation. Precipitation is water coming down in some form. Liquid, solid, depending on the the temperature outside. And so once it hits the ground, it can do a couple of things. So first thing it's going to do, or it hopefully can do, is infiltrate. If you have the proper ground with grass and stuff, it'll infiltrate. Blech. And as it infiltrates or goes into the ground, it falls along down to this where it says rock. Well, that rock is actually the impermeable rock, which means water can't get through it. And it's also called the water table. So that's one way it could flow. The next thing it could do is if there's like too much water or this is too steep, you could get runoff where it follows along down, like bunches into streams, and it goes out into a body of water. So looking at this thing down here, this impermeable rock, when you have all this water flowing down and it gets to that impermeable rock, well, where does it go? It has nowhere to go. Well, if you get over here to a body of water, you have holes or cracks. These holes or cracks are called springs. That's where the natural water comes up into and filters into the bodies of water. And once they get into the bodies of water, you have that huge, beautiful sun, which would be nice right about now, and all that heat to hit you. It hits that water, and what does it do to water? When you heat up water, it tends to evaporate. So you have evaporation going on. Well, what about trees? Trees do have some part of the water cycle to go into it, because it starts sucking up that water from the ground. Plants, flowers, trees, they all start sucking up the water from that. How do they suck up this water? Because defying gravity, it uses capillary action. Now, we'll get into that a little bit later. So it pulls it up. Once it pulls it up into the trees, do the trees have evaporation? Well, kind of, but it's a special type. It's called transpiration. So it's the water that gets into the leaves then evaporate from the leaves. It gets let off, like it's going from the leaves. And then when it gets up into here, you have evaporation going on. You have transpiration going on. Well, when you add them together, you get evapotranspiration. That's the sum of both. That's how much water vapor is actually getting into the air. So once it gets into the air, it comes back over here, flows back over here, over land for precipitation, and it starts all over again. And we're going to go a little bit more into detail about this. And awesome. I did not blank those out. So precipitation hits the ground and it will either infiltrate or run off, depending on the slope of the ground. So if it's super steep, like this, going down like this, it is going to probably flow down first before it can really infiltrate. If it's more like this, kind of flatter, it's going to try to infiltrate more than it's going to try to run off because it's such a gentle slope. How fast the water infiltrates into the ground depends on the soil porosity. It's one of my P words because there's a couple of them. Or the spacing between the material. A soil that has a lot of pebbles will allow the water to infiltrate quickly. Now here we go. You can see right here, the gravel will tend to have more space in between because they're bigger chunks. So there's more spacing in between the chunks. Whereas sand is smaller, so there's less room in between. Now, if you're looking at this, how fast all of this is happening, this is called permeability. That's the rate at which the water goes in. So this takes 2 minutes for the gravel to drain out all the water. Sand takes 20. Silt, 2 hours. Clay, 2 days. So sand, silt, and clay would have a much smaller porosity or spacing between the particles, thus would infiltrate into the ground much slower. So if you have a clay ground, it doesn't tend to infiltrate quickly. How does this relate to you at all? So if you ever get a house and you have septic issues, septics tend to look at what type of ground you have outside. I know this because this happened just last year. I have a clay strip, like just a tiny thin layer of clay going through my backyard. And when they were digging up my yard to see what type of infiltration they'll have for the septic, the first group that I had come here dug right at that clay strip. So they're like, oh, it's going to be horrible. The second group, they dug a little bit differently, and they're like, oh, this is great. You have very loose soil, gravel type soil. It's awesome. So we'll be good. And you just have this little tiny clay strip right there. It's fine. So that's how it does work with you guys. How it's going to impact your lives if you do have septic. All right. So water will continue to infiltrate into the ground until it hits a layer of rock it can't get through. Remember, this is called the impermeable rock layer, the water table. This is where the water table is formed. The water table will be a feeder source for nearby ponds or lakes through openings in the bottom called springs. Those are those cracks that I was talking about. For water to go up into plants and trees through the roots, it first has to go against gravity. So usually gravity pulls stuff down. Well, it wants to go up so that it goes into the flowers and trees and plants. And for this to happen, the spacing or the porosity has to be really, really close. So like with clay, it would be great capillary action going on. That's what it's called, capillary action. So think of it this way. If you've ever had a boba tea, like at the mall, they have those big, thick straws, those big old straws. Now, take one of those big old straws and one of the tinier normal straws that you'd get in a soda. And okay, so I'm a dork. I used to play with my straws when I was in waiting for my food in any restaurant. I would take my finger over the tip of the straw and I'd kind of like tap it and I would make it so the water would go up the straw. That's capillary action. But the difference between the two straws is huge. Like the smaller straw that you would get like a normal soda straw, it'd be easier to pull that water up. Now, if I take a boba straw, which are like, they're pretty darn big because, you got to have your boba, your poppers come up those straws. So trying to like get the water to come up that takes more force. It takes a lot more energy to get up it. So capillary action, you want smaller space, the smaller straw, so that it goes up much faster, much easier. Okay, so water in ponds and lakes and streams evaporate. So we've gone through the springs, the water's coming up, you've got the runoff, it's going into the waters, ponds and lakes and streams, and then it evaporates when it gets hot outside as the water goes from a liquid to a water vapor or gas. Water also evaporates from trees called transpiration, like we were talking about. If you add the two together, evaporation and transpiration, you get evapotranspiration. That's the sum of the both. So as the water vapor rises in the air, it tends to cool because as you get higher up, the air gets cooler. So it cools, and then it hits this thing called a dew point. We'll get into those two facts in a couple units called meteorology. For right now, just know as air rises, it cools, and then it hits something called a dew point, where it goes back to little water droplets that forms the clouds and starts this process all over again. So as soon as it evaporates, it cools, forms clouds, goes back down into precipitation, which eventually gets into the ocean by either runoff or whatnot. And then you have evaporation and transpiration again. It just keeps on going. All right, so the notes are done for today. Make sure you have done your pre-test or pre-assessment, post-assessment. Post-assessment on the last unit. The pre-assessment was on this. I hope you did it before watching this. And then you guys had your Kahoot vocab. Please do not forget to do your Kahoot vocab. Make sure you're setting it to public. You click on the share button and you copy that link. Then go back into the classroom, click on create, add the link, post it, submit everything, and you're good to go. Besides that, I hope you guys have a nice day. Don't forget your Zoom meetings with me. If you have questions, 9:30 to 10, 1 to 2. If you need to see me outside those hours, please get in touch with me. Maybe we can do a one-on-one if that's what you need. Besides that, again, have a great day.